Okay, so I'm going to talk about ceratobogonids, and I'll briefly mention one other family in here when I show it. But ceratobogonidae are the biting midges. They're also called no-see-ums and punkies, and to the non-medical entomologists, they're called sandflies. Medical entomologists have a big issue with them being called sandflies because there's another group of flies which are called sandflies. But in reality, they're sandflies. When you deal with the public and the public says, I went to the beach and I was bit by sandflies, they're talking about ceratobogonids. And this is why common names are a problem. So they're just like mosquitoes, holometabolites. They're insects, they're diptera, they're seeing the same 4 life cycle stages, so they have eggs, larvae, pupae, and adult. Unlike mosquitoes, ceratobogonids have the full range of habitats, and I'll talk about them on another slide. But there are terrestrial ones, there are aquatic ones. For all I know, there's probably a parasitic one. There's certainly some that live inside plants. So very diverse. Unlike the mosquitoes, mosquitoes there's maybe 3,000-4,000 species, 5 be my guess tops that we know names for currently. Ceratobogonids have thousands of species. It's a really diverse group of flies. And of those thousands of species, really we only worry about 3 genera. Because for the majority of the ceratobogonids, they are blood feeders. They're almost all blood feeders, but they only feed on arthropod blood, and I'll show a photo of that in a second. We worry about the genus Culicoides, which is a very primitive genus. Forsythia, and usually we only worry about Lasohelia, so it's a subgenus, and Leptoconops. And when someone says, I went to the beach and I was bit by sandflies / no-see-ums, they're talking about Leptoconops. Life cycle. So it's got a very small egg. The larva for Culicoides, the one we worry about the most, is this sort of wire whipworm sort of looking, mostly aquatic, writhing little larva. The pupa, here's the pupa or pupae of the Culicoides. And the other ceratobogonids look very similar. These can move, the pupae can move, they can crawl through mud, but they don't swim like mosquito pupae. And I mentioned using silver nitrate to show where the osmoregulatory organs are. If you actually look at this pupa here on the right, you can see there's all these dots down the center and some sort of speckled dots here. That one's been stained with silver nitrate versus this one, which has not. It's a little harder to tell on that picture, but when you get close up to one, you can see it. And this is the adult. Okay. So most ceratobogonids, the majority of species, feed on insect blood. And if you imagine, this is a dragonfly wing, and if you take a look, there's a female here. All right, here we go. There's a female here feeding on the vein on the dragonfly wing. On the opposite side is another female feeding on the vein of the dragonfly wing. You'll see this on butterflies. You'll see this on caterpillars. All sorts of insects get fed on by ceratobogonids. And they might even transmit diseases to them. I've read several papers where people catch these ceratobogonids feeding on an arthropod, and within 24 hours or 48 hours, the arthropod dies. Now they're clearly, they fill up with blood, but they're not filling up with that much insect blood, so they're not exsanguinating their host. They're doing something. All right. Now, the ones we worry about feed on blood, and so here's an example. This is Culicoides sonorensis on human skin here, and they're feeding on blood. This is where they're a pest and where they transmit diseases. And then they don't all feed on mammalian blood. There's some that feed on, say, amphibians. So this is a frog's leg here. There's the knee. These are feeding on the frog, and in actuality, these are corythrellids, which is the other group I was going to mention. They're very primitive nematocerans. They're very similar to mosquitoes and ceratobogonids, and they feed on amphibian blood. There's also, the reason I use this slide is because short of a really close magnification, you can't tell them apart. These guys are pretty cool. They transmit pathogens to frogs, and they only transmit to male frogs because they find their host by sound. So if you wanted to trap the ceratopagonids or chlorthrellids that feed on frogs, you do it by setting up a light trap, taking the light out, and putting a microphone with a frog call on it. And they come to the frog call because they're going after the frog. But only male frogs call, so they only bite male frogs. And if you look for, say, trympanosomes in frog populations, the vector-borne ones are only in males. Alright, so where do these things live, larval habitat-wise? The primary pest species live in wet soil. So if you were looking at this as a rice paddy here in Japan, and this soil, which is waterlogged and has been waterlogged for months, it's full of ceratopagonid larvae. So they're crawling around in fully submerged wet soils. They'll live in sand, and this is where you get your, quote, sand flies, the ones that are on the beach. Leptoconops will live in wet sand. They live in tree holes, so the same places you find tree hole mosquitoes, you'll find tree hole ceratopagonids. The ones that live in tree holes will also live in containers. So a lot of places you'll find mosquitoes, you'll find ceratopagonids. They love living in swamps, so the same sort of wet soil scenario, but natural ones. There's some that'll live in leaf litter. Doesn't even have to be. It's not going to be totally dry leaf litter, but it can be just slightly moist, and they're crawling around. They're not writhing like nematodes. They've got little rudimentary legs, and they're crawling around and eating other arthropods or debris. And then there's even a species that lives inside rotting cactus fronds. So it's got the same body shape as this, sort of nematode-like, and it's crawling around inside the rotting parts of plants. So there's a huge diversity of locations. So why do we care about them? First reason we care about ceratopagonids for medical and veterinary entomology is they're pests. If you ever go to a place that has a big biting midge population, you know that it's a pest. They can drive away business. They're very painful feeders because the mouth parts to the ceratopagonid, I'm going to zoom back for a second. The mouth parts, here's the mouth parts on the top right of this slide. These are not like the mosquito mouth parts. These mouth parts have blades on them. And so what these guys do when they feed, as you'll see here, is they produce a little blood pool inside their host. They cut with those mouth parts down in there, and then they suck up the pooled blood. That is, in the end, far more annoying and painful than a mosquito bite. So you see this with horseflies and black flies and a lot of the biting flies that are pool feeders. That's what it's called when they make the little blood pool. It itches a lot. It's quite painful. So just like with mosquitoes, ceratopagonids are huge pests, and they can have a big economic impact. Then they also transmit pathogens. For humans, there's a really small list, with the exception of some locations in South America and a few other places in the world. We really exclude them in the list of major vectors for medical importance. Veterinary importance, though, they're very important because they transmit a number of veterinary diseases. And for example, this sheep, or it's not a sheep because that'd be plural, this lamb has blue tongue, and its tongue really is blue, and it's about to be dead. It's quite sick from a disease transmitted by Culicoides. And I'll go into Culicoides diseases and a case control later. So we talked about mosquito control. All of the same steps in control are needed for Culicoides control. You need to know surveillance, what species do I have? And unlike mosquitoes, it's a much more difficult question because every state has someone that can probably identify the mosquitoes at their public health laboratory. Mosquito abatement districts have people who can go out and identify mosquitoes, possibly not even using a microscope. They've seen so many, they're really good, they can do it. Culicoides, you may have to slide mount their heads and pull their wings off and look at genitalia, and it's a really complicated question. So surveillance can be a big issue because you may not know what you have. You may have 2-3 species, could be a problem. Then IPM-wise and chemical control-wise, if this was a mosquito population, the mosquitoes are out here in this pond, and you could treat this pond, or you could drain the pond for quite a while and then get rid of the mosquitoes. The Culicoides, however, are living in the mud here, it's very difficult to chemically control anything that lives in mud because mud locks up pesticides. It just flat out prevents chemicals from getting to it. It's not open water, and so it is very difficult to control a lot of Culicoides. On top of that, pest control companies have not spent the money to label products for Culicoides biting midge control that may have been labeled for mosquito control. So it's a much more complicated question to control them. So I'm going to talk about one major group of Ceratopogonid / Culicoides, is the genus that transmits it, diseases. And I'm going to talk about a blue tongue outbreak, give you some background on blue tongue itself and EHDV and other viruses. But talk about how big of a deal is it? And as you can see in this picture, this is a bunch of dead sheep. They're going to be mostly used, but these animals died in an outbreak in Montana. It was right on the border of Montana and Wyoming. Alright, so background. Blue tongue, and you saw the photo earlier of the animal with a blue tongue. Blue tongue, we have outbreaks of it in the United States. It's particularly common in the Rocky Mountain region. It's an animal disease. It doesn't affect people. It doesn't affect non-hooved animals. And as far as I know, it doesn't even affect horses. So it's got to be split-hooved animals, cloven hoof, as you would say. It's transmitted in the western United States by Culicoides sonorensis. And when I mentioned difficulty in working with Culicoides, there are 3 species that look identical without high-level magnification. So sonorensis is one of those 3. They don't all transmit blue tongue. But it is the vector in the Rocky Mountains. And it's only a vector where it exists. It doesn't live in really, so if this is a cloud-topped mountain here with snow, high elevation, sheep are essentially immune to this disease because they can't get bit. And so most of the year, these animals are taken up high into the mountains where they're allowed to roam around to the pastures and gain weight. They spend a large portion of their year at high elevation. They don't get any disease because there's no vector. But in late summer / early fall, depending on where you are in the mountains, you got to bring your animals down to your ranch so that you can shear them, so that you're going to sell some of them off for food. And that happens to be at the time of year when there's a really large population of biting midges. And those biting midges have probably been feeding on wildlife and rams. Those would be the male sheep, intact male sheep, at low elevation. And so there's been an ongoing disease epidemic down here at low elevation while your immune population is up here that sees no disease. So they come down late summer and fall, and they get exposed to the virus, and they only have a narrow window for this exposure because once you get into September, it's going to start freezing and you just don't see biting midges. So let's talk about the virus, blue tongue, which is abbreviated BTV, and a very closely related disease, EHDV, epizootic hemorrhagic disease of deer virus, are both in the genus Orbovirus. They're in the genus Orbovirus. There are other orboviruses that affect mostly wildlife, but there's one in horses, which is African horse sickness. They all have a very similar set of signs and symptoms. So they usually cause fever, and it could be mild, but often it's quite severe. They cause internal bleeding because they're blowing apart capillary beds. So internal bleeding, which is what causes that drooling and blue tongue. They cause swelling because there's fluid loss. They cause lesions, and this is the problem for the U.S. Department of Agriculture. They cause lesions, vesicular lesions, so they're going to be around the mouth. They cause damage to the coronary bands, and that's where, if you imagine you have your leg here, and then there's this hoof. The coronary band is this band between the hoof and the leg. And if you damage that well enough, the hoof can actually slough off, and that's going to be fatal. And the disease is actually often fatal. If it's not fatal, it's often secondarily fatal because if an animal can't stand and it's leaking, it's got leaky fluids and it's internally bleeding, it'll get fluid in its lungs and it'll get pneumonia and die, not from blue tongue, but directly related to it. Now, why is it a big problem outside of killing sheep? Is because vesicular lesions with mild to severe fever looks like foot and mouth disease. Foot and mouth disease is on the top 2 most important veterinary pathogens in the world, and if you have an outbreak of it, your country is quarantined. No one will buy agricultural products from you. So when you have an outbreak of blue tongue, it looks just like foot and mouth superficially, and so it's a big issue. All right, it's a virus, as I've mentioned. It's a virus, which means it is incurable. Oops, I did something funny there. Incurable. But you can treat symptoms. It's also interesting, hard to cause in the laboratory without infecting midges. If you inject a lamb with blue tongue virus, you have to give a massive dose of virus versus if I let an infected midge feed on it. Uh-oh. Something has happened. Okay, there we go. So 2007, in late 2007, there was a big outbreak of blue tongue in Wyoming and Montana, and ranchers are beginning to suffer some severe losses, and they were also getting quarantined, so they could not sell their animals, they couldn't transport them from county to county, which was costing a lot of money. What we did is we talked to some ranchers, and I was involved with a follow-up to this outbreak. Well, some of them were able to actually prevent their animals from dying, and so what they would do is they would, and this is an animal that died of EHDV, but they'd keep the sheltered animals. They had a fever, so you're keeping your animal from being too exposed to the environment to control its fever. They would tube them, so the animals wouldn't drink, and they were dehydrating, so you could tube an animal, give it enough hydration that it doesn't die. They wouldn't eat because their tongues were swelling and their teeth hurt. So you could give them silage and get it wet and warm so that it was palatable and the animals could chew it. Because once they made it through all the symptoms, they recovered. If they didn't die, they weren't permanently suffering from swollen blue tongues. They would get better. They would clean out their mouths and everything, make sure the sores didn't get infected using salts. They give them antibiotics. Now, I think the antibiotics did 2 things. They prevented secondary infections, and some of them are anti-inflammatory. So doxycycline, for example, is anti-inflammatory. And then they restricted the animals. It just kept them from moving around a lot so they didn't get stressed. Okay. Saved one ranch that did this, saved almost all of its animals, had very low mortality. The problem is it's extremely expensive when you have... I'll show you this. This is the ranch that did it. These animals here, this is probably 1/10, if less, all of her animals. She's got this pen that just keeps going and going and going, full of sheep. If every one of them is being treated this way, it costs a tremendous amount of money. And since there are no antiviral treatments, they could only treat the symptoms in the animals. Now, as a little bit of background, there's a vaccine for blue tongue, but it's state restricted. You can only use it in states with the particular virus, so it's actually a live virus vaccine. There's also a killed virus vaccine, but you can't guarantee the virus is killed. So states may say no, you can't use that virus here. With a foreign, like Wyoming could say you can't use the California vaccine. So there's a vaccine. It doesn't protect against all blue tongue, and it's expensive. Also, just because you've been vaccinated against, say, blue tongue type 1, it doesn't protect you against blue tongue type 2. And there's more than one type in the United States, so it's an expensive thing to decide, do I want to vaccinate? Transmission, I mentioned earlier, is exclusively a natural transmission by culicoides, by biting midge. There's non-natural ways to transmit it, but we don't worry about that. Cervids, that would be your deer, your elk, your moose, and cattle are susceptible to infection, but cattle almost never get sick, so they're just reservoirs. And we know for sure that animals that are viremic, they can be infectious, and probably are infectious before they get sick. So quarantining doesn't always do a lot of good because everything could be sick before you move it, and then you won't know that they're sick. So when we talk about an outbreak and we want to prevent the next year's outbreak, things you have to think about in the very real world is the amount of money I spend to control a blue tongue outbreak or any outbreak, regardless of what it is, has to be, if you're talking about agriculture, has to be less than the amount of money I'm going to lose if just I lose animals. So, and you can modify this for humans. We have a far lower tolerance for saying lives lost, and money, but certainly for agriculture, where we were talking about money, you have to think about money spent has to be, if I just lost animals, has to be a positive break here. So I could use a vaccine for blue tongue, but they're extremely expensive compared to the risk of the disease, and outbreaks are rare. I don't want to vaccinate every year. The last time they had an outbreak in Wyoming was 20 years earlier, a big outbreak. So vector control, well, that works if you have access to breeding habitats, but we're talking about huge expanses of open land, so you would have to aerially spray, and you can't do that in a lot of places. Now, repellents, almost never used on livestock, but only work if they can be applied easily and they have to last long enough to prevent transmission. But that's actually what we worked on. Alright, so we're talking about a vector-borne disease in livestock. And because they're vector-borne, we can prevent them if we can keep that vector from getting to the host. And we can also prevent it if we prevent them from getting to infected hosts, because you can't spread it if you can't feed on things. So we're talking about these biting midges, keeping them off their host. Wah. We wanted to prevent blue tongue by keeping Culicodes sonorensis from feeding on sheep. Now, we knew that we know some things about where they feed. If you're a small fly, it is next to impossible to feed on a lamb or a ewe, that would be the baby or female sheep, anywhere other than underside, because they're covered in a truly thick layer of wool. We do know that they'll feed on the face, and I don't remember if I have a slide. Rams, intact male sheep are different because their testicles hang about 2 feet below them, so they have a huge target to be fed on. So sheep also, and this is different from a lot of the other livestock, sheep also produce a chemical which is called lanolin. Lanolin, you use it in hand soap. It's an oily material, so sheep are covered in lanolin oil. They rub all over each other because they're social animals, and it makes actually a really great target for insect repellents, because insect repellents are fat soluble, some of them, and you don't have to treat everyone when animals like to rub against each other. You can actually miss targets animals, and they still treat each other. So we wanted to see if we could apply some relatively long-lasting, not super cheap, but very cheap insecticide/repellents to sheep effectively, and see if this could be used to control blue tongue. So we had a bunch of randomly assorted weighed numbered sheep, and looked at manufacturers' doses. Now, most of these were not approved for sheep use, so we had to pretend like the sheep were calves, but dosage-wise, do that. And then we would take unfed Culicodes sonorensis from a colony and put them in these tubes. And we could hold tubes on the axillary area, which, if you're not familiar with animal morphology, that would be the armpit. But I guess sheep don't have arms. The leg pit of the sheep. So we could we could basically do feedings and see, okay, if I take pesticide-treated versus untreated sheep over several weeks, can we treat them once and prevent biting midges from feeding on them? And remember, because there's this really narrow window between when I love that I can draw on this. They come off this tall mountain down to the lowland, and then it freezes. About 3 weeks later, I only have to prevent the biting midges from feeding in this little narrow time window. So how do we do this? Different ways to apply insect repellent/pesticides to sheep. One would be to put ear tags. If you've ever looked at livestock, often they have ear tags. Sometimes they're numbers, like this one here, 441. That's just a numbered tag. Other times those ear tags are insecticide treated, and the insecticide sort of leaks out. Most of the people watching this will be too young to have experienced this many times, but a lot of old shower curtains had this problem where the plastics were not completely compatible, and you'll still see this with some plastics where when you get them in packaging, they're okay, but they become sticky and stick to themselves later, and that's because the plastics are coming apart. They're incompatible with each other. The way these ear tags work is it's a rubbery latex ear tag. It has impregnated in it a pesticide which leaks out because it's incompatible with the ear tag. And so it's constantly coming out at a low controlled dose. And it gets all over the sheep, and they get it all over each other. The other option was to spray the sheep. So this is a sprayer where we can deliver an exact dose. If it's actually a popcorn sprayer, but it's an exact dose of pesticide which we're going to apply to the sheep. And in the real world, you would have them running through a chute, and they just run through the mist of pesticide. And this particular sheep it's been treated with both. And then, as I was mentioning, we could hold these tubes. So here's a tube zoomed in, and here's Mr. Yarnell holding it right there against the axillary area of a sheep or a lamb. For 15 minutes, and this is just to give you an idea what it looks like, and you see what biting looks like. This is a repellent treated animal's axillary area. It wasn't shaved. There's no modification. This is what sheep leg pit looks like. There are no red dots. This is what happens when they were untreated. So that's all those red dots are biting midge bites in just 15-minute time span. Originally, this is for those of you who ever do entomology research, the original plan, before we used these tubes, by the way, was to put sheep in a stanchion. So that's a stand right here, and they'd be collared in so they couldn't escape. And then put a drop net over them. And then I bought a DVAC here. This looks like a Ghostbusters backpack with a big vacuum and a tube that catches sheep. And we released 10,000 midges into the cage, let them sit there for 30 minutes, and then I went in and vacuumed them off the walls. We got less than 1% capture, so it didn't work. And if you ever do entomology research, you'll find these things where you have a great idea, so it seems, until you act it out. So we looked at a couple different chemicals. One would be, and this is going to give you some ideas. Python is the name of it, but it's a pyrethroid, and it has a synergist piperonil butoxide, which is not really toxic in itself, but it prevents the breakdown of pyrethroids. So it greatly enhances how toxic they are to arthropods. And after our work, it got EPA approved and state approved to use it in Montana and Europe, and then Montana and Wyoming, and then there was some possible acceptance in Europe. We used the ear tag. Now it suppressed 80% blood feeding for 4 weeks. You only had to put one ear tag on. Ear tags are about 10 cents an animal, if I remember. So you could treat them as they come down from the mountain. You're trucking them over to your ranch. You just tag them as they come off the trucks, and they should be resistant to blue tongue. So it gave 80% reduction. It gives even after that, for at least 5 weeks, it reduces the amount of engorgement. So even though they're feeding, they feed even less. If you're untreated sheep, but 52% of the biting midges engorged. Treated sheep, far less. We looked at some other ones, like the spray, the one you saw me spraying on there. It's 2.5% permethrin and PBO. This is that synergist again in oil, and the reason it's oil is so that it can spread across that lanolin layer. And we saw that one work. It prevented engorgement for 3 weeks, but it probably only gave 2 weeks of effective control, which is not good enough. We did a pour on, that is literally as it sounds. If you've never done livestock work, you pour it over the top of the animal. It gets used a lot for things like tapeworm control or tick control. They pour ivermectin on their animals, so it's a very well used veterinary or ranching procedure. Same setup. It did not work. We did the combination treatment, and this worked great. It gave, almost complete protection for 5 weeks. The problem is it gets expensive. Now, we did also make another discovery when doing this, and this will happen when you do entomology research. Sheep in Wyoming and Montana have another ectoparasite called a KED, which is a wingless fly that damages sheep hide and can be quite annoying to the sheep. The one control method for KEDs had been dropped by the company that was making it, but we found out that the ear tags and the spray completely remove the kids from the sheep. And then we looked at some European products. This came from Germany, which is a cyfluthrin. It's not a repellent, and so one of the problems with it is it just kills the midges after they feed, according to the research out of Europe. But it wouldn't necessarily prevent them from getting infected with blue tongue. And as it turns out, even though this is a direct quote out of a German publication, that it kills them for 3 to 4 weeks, we noticed that it didn't ever kill them. Not everyone wants to use synthetic pesticides for their control. And I, as an entomologist and as someone who's got some environmental concerns, I understand this. And I think it's great to look at alternatives. So we looked at geraniol, which is, essence of lemongrass. It's a non-restricted chemical in terms of being able to use as a pesticide. It's what's called EPA 25B list, so you don't have to get a special label for these. They're considered food additives, basically. And it's been proposed as a long-term repellent. So we looked at it at a 1 to 49 water-soluble formulation, and we sprayed some sheep with it, and even within a few hours on the same day that it was applied, it didn't appear to have any statistical benefit. And I guess I should add this because I don't include it on another slide. The one thing you have to be careful with some, and you have to be careful with this with synthetic pesticides too. This is a big one to think about if you're ever doing organic control. This is a food additive. It can sensitize the host. It's one of the ones that causes a skin sensitivity. If you use it as an insect repellent and you sensitize yourself or your pet or your livestock with it, and then particularly with humans, is sensitize yourself and then eat things where it's used as a food additive, you really increase the chance you have a severe adverse allergic reaction. So that's another reason we kind of didn't like it, but it didn't work. So follow up, after we had this big outbreak in 2007, turns out 2008 was a really cool year, and they didn't have a big biting midge population that year, and we basically had almost no blue tongue. And the repellent use we don't know because without the outbreak, no one really jumped up and down and said it worked or it didn't. But this is what it looked like the year there was the big outbreak. So.
Okay, well that's the end of topic 7-1. I wanted to thank Dr. Reeves again for providing us with that lecture, and I will talk to you again soon in topic 7-2.